Hi everybody. We are recording now, and we're gonna do the yellow problem. So, which is even problems. Uh, so identify the elementary row operation being performed to obtain the new row operation. So the original matrix. Here's the original matrix. And here's the new matrix. Well, notice that the top row is the same. So whatever happened it didn't happen to the top row. The top row may have been part of it, but not the top row. With the bottom row, the second row did get changed. It looks to me like I'm taking thrice the top row, adding it onto the bottom row, and that's my new bottom row. Because 3 times 3 is 9. 9 plus -4 gives me +5. -3 plus +3 gives me 0. And -12 plus 7 gives you -5. So I'm going to say three times row 1 plus row 2 becomes new row 2. That's what I'm reading. I'm not bothering writing it down. I'm write it down. Okay, for 10, I see that the top row stays unscathed, but I couldn't help but notice the zeros down here. So I guess what I'm doing is my guess, and work this out to make sure this on all the columns, but I'm going to say -2 times row 1 plus row 2 becomes a new row 2. And I'm sorry, +2 row 1, +2 row 1 plus row 2 becomes a new row 2. And then +5 row 1 plus row 3 becomes a new row 3. And you can see that I'm not going to go through it. You can see that all the numbers are going to work out beautifully. Okay, I'm not going to dwell on that for Let's look at this here. So we want to find the solution set of the system of linear equations represented by the augmented matrix. So let me share stop the share. So this is number 12. The number 12, by the way, that's really just saying x equals 2, y equals 3. That's really what it's saying. Because that column represents the x's, that column represents the y's, and that's the constant. So this is just saying 1x. This top row is saying 1x plus 0y equals 2. In other words, x equals 2. This is saying 0x plus 1y equals 3, or y equals 3, and that's it. I mean, that's the whole thing. So that was actually quite simple. For 14. So 14, this is our matrix here for 14. And this would be x plus 2y plus z equals 0. And that tells me z equals -1. So let's go back to the paper here. So x plus 2y plus z equals 0, z equals -1. Well, I'm going to take this and substitute that to the top equation. So I get x plus 2y minus 1 equals 0, or x plus 2y equals 1. At this point, I have one equation with two variables. So I'm going to turn y into a parameter. X is just going to be 1 minus 2t. You see that by solving for x. And this is my solution right here. So 1 minus 2t, t and negative. There you go. And let's look at number 16. Let me go back to share the screen so you see number 16 again. Oh, I didn't even. So this matrix down here is number 16. And that represents 2x, this top row represents 2x plus y plus z equals 0. That's x minus 2y plus z equals -2. And that's x plus z equals 0. So let me stop sharing so we can show you that. So that's number 16. And I turned that into the matrix now. And now again, there's not necessarily one way to do this. This is how I'm choosing to do it. I could divide the top row by 2. Then I get all these fractions. I don't want to do this. I'm going to switch row 1 to row 3. I'm allowed to do that. And then the next thing I'm going to do is I'm going to add negative row 1 onto 2, become new row 2. I'm going to add negative 2 row 1 onto row 3 to make that my new row 3. Now, you got to be careful. I did something you got to be careful with. Usually you do one operation, you do an operation, you change the matrix, you do another operation. You don't do 2 operations at once and then change the matrix because you might screw things up. But here I could do it because when I do the operation, see, the problem is I have row one and row two, becomes the new row two, new row two. Well, if my second line involved had a row two involved, that would have to be the new row two after this change. And if I do it all in one shot, it gets a little confusing. But here, there is no row two down here, so these two operations are totally independent. So that's why I'm safe to do this. Anyway, after doing these operations, I get 1, 0, 1, 0, 0, negative 2, negative 2. Now, I can go further, but the truth is, I can see already with this calculation, this second row is telling me, if I convert this back to an equation, negative 2y equals negative 2, hence y equals 1. The bottom row tells me y is equal to 0. So it's got to be one or the other, it can't be both. It's contradiction, hence number 16 has no solution. Okay, let's go back to Let's go up to 18. And number 18, well, number 18 is also going to be a contradiction because a bunch of zeros here and 2. This says 0x plus 0y plus 0z plus 0w equals 2. In other words, 0 equals 2, which is also a contradiction. So 18 is also no solution. Okay, let's look at, I just want to do this next set, the row echelon form, just to say all these guys in row echelon form. So let me just here. All right. So now we're going to do 20. It's going to do 20, 22, and 24. Well, 20, no, it's not, because the top, the leading rows on top have to be moved to the right. Now, if I would switch row 1 and row 2, this would be row echelon form, but right now it's not. For number 2, well, number 2 is perfect. That's perfect row echelon. I mean, picture perfect. Number 20 is what I'm saying. Number 24, well, number 24, yeah. I mean, there's a leading one over here. There's another leading one down there. Now, you may say to me, oh, no, this is a contradiction. Yeah, because that's 0 equals 1, blah, 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 blah. And I say, wait a minute. Not every matrix represents a system of equations. We could take a system of equations and represent it as an augmented matrix. But that doesn't mean that every time we see a matrix, it has to represent the system. It could be matrix, could be some other thing. Matrix is just a rectangular array of numbers, and it can have a lot of different meanings and interpretations to it, and so forth. Anyway, that's all I wanted to do for now. It's been very lovely, and we'll see you guys in the next video. Okay, bye everybody. Bye.